let's get started. Pause my book that I've been listening to. Alright. Current flow in the capacitive branch of a parallel RC circuit blank the voltage. So, what we left off on the last lesson. Let's open up Paint again. Speaking about current flow, remember ICE. Current, voltage, capacitance. So current is ahead of voltage in a capacitive circuit. Let's compare that to our question. Current flow in a capacitive branch of a parallel RC circuit blanks the voltage. Well, the current leads the voltage. I'm almost out of frame. Raise up that arm. So if I lean, I don't lean as far. Alright, what is the total resistance for the circuit in the figure below? Ooh. It's a good one. Given R1 equals 100 ohms, R2 equals 250 ohms, C1 equals 5 microfarads, and C2 equals 10 microfarads. This is a good question. So, how do you combine resistors in parallel? With the Pythagorean, not the Pythagorean Theorem, with the reciprocal method. You can't just straight up combine all of these. I'm actually going to open up this picture. Give me 1 second to find it. AC circuits. Let's change that to the extra large icons. We want. That's it. Oh crap. Let me start all the way over. Let's see. Open with Paint. Resize. 3 times should be plenty. Resize. That's plenty big. The actual picture isn't super important, but okay. So we got. I forgot the numbers at this point. 100, 250, 5, and 10. We got 100 ohms, 250 ohms, 5 microfarads, and 10 microfarads. Let's start with the resistance, because you can't just smash all this together in one equation. The resistance is going to be the reciprocal method, so we're looking for R total. Opens parentheses 100 to the power of -1 plus 250 to the power of -1. Close it, 1 more to the -1. Use our calculator. 100 plus 250. Close it 1 more time. -1 one more time. 71.43. So our total is 71.43. And then now we need to find X of C total. There's 2 different ways we could go about this. I'm going to show you what I consider to be the easier way. You have to remember less steps. You're going to convert both of these individually into X of C. So X of C1 is 1 over 2 pi times 60 times 5 microfarads. That would be 1, 2, 3, 4, 5, and 5. That's going to be, plug that in the calculator. We're going to do that by doing open parentheses 2 times pi times 60 times 0.12345 5. Close the parentheses and do one more x negative 1. So that is 530.5. Ohms. X of C2, basically going to do the same steps. I'm going to make a guess, and it's going to be 215.25. But let's, because the farads are doubled, so the x of L is going to be half. But 2x of C, 2 pi 60 times 0.00001. That's moving. Micro is 6. You move the decimal 6 times. That is what we're getting. So again, with the open the parentheses, 2 times pi times 60 times 0.00001. Close my parentheses, do x negative 1 one more time, and I was not quite right. 265.25. That's because I cut it in half the wrong way. Alright, now we do the reciprocal method. So open parentheses, 530.5 to the negative 1 plus 265.25 to the negative 1. Close it, one more negative 1. And this will give us x of C total. Back to the calculator. Open parentheses. Let's clear that. Open parentheses. 530.5. Negative first power plus 265.25. Negative first power. Close the parentheses, one more to the negative first power, 176.83. Ohms. And this is ohms as well. So, now we have a circuit. This circuit has turned into this. And that will be our total is 71.43 ohms. I started too close. X of C total is 176.83 ohms. So we have these two legs. We have 120 volts. We could go into our book, get the formula to do this. All in, like, do this with a formula, and it's a crazy formula. Or we could find our ohms, because the current is going to be easier to combine than the two resistances. Alright, so we're going to find our current. We're going to find I of R. I of R and I of C. We're going to use Ohm's law to find these. So 120 divided by 71.43, 1.68. And one more time, 120 divided by 176.83. Oh, I didn't actually look at the number. 0.68. Okay, there we are. So now we're going to use Pythagorean Theorem because we are on a triangle at this point. Oh, well, I'll just go ahead and use a triangle. With I of R equaling 1.68. And the reason we are using triangles all over the place is because all of these things are 90 degrees out of phase with each other, and combining with vectors puts it as a triangle. That's why I'm just seemingly randomly pulling out triangles. In parallel, the only triangles are the current triangle and the power triangle. All else fails, you can go all the way to power and use power to find things. Remember in, I'm way past this, but in parallel, voltage is the same on both legs, so E of R and E of C are both 120. So there's no triangle because they're all at 0 degrees. Okay, and then I of C is 0.68 amps. So now we just have to do I total is square root of 1.68 squared plus 0.68 squared. Oh, I didn't notice those numbers were very similar. All right, open parenthesis, 1.68 squared plus 0.68 squared, close my parentheses, take the square root of that, 1.81 amps. I total is going to be 1.81 amps. So, I'm going to clear this top part. I total is 1.68, no, 1.81 amps. E total is 120 volts. Z total for this circuit is going to be 120, and just using Ohm's law, 120 divided by 1.81, 66.29. All right, and that is our answer to this question, should be. I bet it's going to be 71.4. Yeah, there was a lot of rounding happening. I'm willing to bet I was supposed to use 3.14. Yeah, I rounded all over the place and probably should have, kept some of that more real. The numbers would have been quite a bit higher. Uh, but yeah, I find that uh, I'm 5 off, 5 ohms off. That's not that big of a deal. To help you narrow this down, though, without doing a touch of math, once you saw that all the pieces, so in parallel, the total will not, the total resistance will never be larger than any of the legs. So once you saw that one of them was 100 ohms, one of the legs was 100 ohms, you can knock out C and D. Because it can't be over 100 ohms. That brings you to 71.4 and 2.5. Then, as we see that the two legs, like, we had 71.4. Did I just overdo this circuit? What is total resistance? Oh my god. So, don't do like me. Read the question. Total resistance for the circuit. They only care about the resistance. They don't care about the capacitance. Resistance only. So, whenever I got to here, 71.43, I was done. I didn't have to do the rest of the circuit. So, again, read the question. Damn it. Alright, moving on. What is the total capacitance for the circuit in the figure below? Okay, same circuit, different numbers. So I don't get to use my numbers. Damn it. 500, 100. Yeah, they've changed it. They've changed it just enough that I can't use that same math. But same steps apply. But remember, read the question. They only care about capacitance in this circuit. So I'm still like, damn it. So there's two ways to do this. I'm going to stick with the same way just for consistency's sake. So capacitors in parallel combine like resistors in series, but whenever you go to X of C, it works just like resistance. So that's why I suggest doing X of C. So let's grab that, clear that, and clear that. So C1 is 500 microfarads, which is it's 6. So 1, 2, 3, 4, 5, 6. So it's 3 zeros. And then this one was 100 microfarads. So that's 1, 2, 3, 4, 5, 6. That's again 3 zeros. Your two formulas are, so your formula is 2 pi f c, where c is in regular farads, not microfarads. So you're going to have 0.0005 and 0.0001 is what you're going to plug in. Your frequency is 60. I know I pointed at the screen. You can't see that. The frequency is 60. So let's just throw that all in the calculator. Open parentheses. Let's clear this. Open parentheses. 2 times pi times 60 times 0.0005. close parentheses, one more. So that's going to be 5.3 ohms. And this other one's going to be 5 times that. So let's, okay. 2, okay. Open parentheses, 2 times pi times 60 times 0.0001, close parentheses, 26.5. Ohms. So now you do, you just do the reciprocal method at this point. So it's open parentheses, 5.3 to the negative 1 plus 26.5 to the negative 1, close parentheses, 1 more to the negative 1. Oh, wait, gotta put my parentheses. 5.3 plus 26.5. Close the parentheses, 1 more to the negative 1. 4.41 ohms. And watch, I think I'm going to look back and see I misread. They were asking for total capacitance, not total capacitive reactance. Total capacitance. Yep. So, capacitors in parallel combine like resistors in series. So capacitors in parallel add up. We have a 500 and a 100. It's 600 is the answer. And I just told you to read the question. So it's good that we're going over these, because you need to read the question. Yeah, see? See? They add up. Which figure below correctly shows the phase relationships between current and voltage in a parallel RC circuit? It's been 22 minutes. We're on question 4. Current and voltage parallel RC circuit. So current leads voltage. So A looks promising. Current is leading voltage. But here current, but it's I of R. Yeah, it's A. Because current is 90 degrees ahead of voltage. Current for the circuit in the figure below. Probably they've given us something super easy. They didn't. So you have to find the different currents down the different legs. 40, 60, and 80. So it's so E. Oh wait. R Z X of L and X of C. 40. Oh, I don't know if that's exactly how it goes. Hang on. 60, 80. Yeah. Hey, I was doing it right. Ohms. I, we don't know any of them. E, and E. And it was 120. And it's just 120 all the way down. So now you just take your calculator, divide it out using Ohm's law. Divide by 40 is So this one is 3 amps. 120 divided by 60 is 2 amps. And I'm not going to divide by 80. 1.5. Okay. So we have 3, 2, and 1.5. X of L and X of C cancel each other out, though. So 2 minus 1.5 is 0.5. So we have a triangle, current triangle, to get our current total. This side is 0.5 amps, and this side is 3 amps. Using Pythagorean Theorem, square root of 3 squared plus 0.5 squared open parentheses 3 squared plus 0.5 squared close parentheses. Square root of that is 3.04 is our answer. Let's see what answer options we have. 3. Yep, that's it. All right. You would not add them together because that's not how current works since they're at different angles, all the different currents, you can't just add them together. You have to use vector combination. All right. What is the resonant frequency for a circuit with a 1.1 microfarad capacitor and a 5 Henry inductor in parallel? There's a formula for that. You will need to look it up, and you just plug the numbers in. There's nothing really special about it. I have added. There it is. Oh. And you just plug the numbers in to the formula. I'm not going to spend too much time on resonant frequency. We got a whole deal with that later. What's the capacitive reactance of a circuit with 80 ohms of inductive reactance at resonant frequency? What resonant frequency is the number where inductive reactance and capacitive reactance are the same. So if you have 80 ohms of inductive reactance and it's at resonance, you have 80 ohms of capacitive reactance. That's literally all it is. The vector diagram in the figure below represents the phase relationships between currents in a parallel RLC circuit. Which vector represents the current through the resistance? C. C represents the current through the resistance. Current through the resistance is always at 0 degrees. Phase relationship of current in a parallel RLC circuit, which total current? Total current is going to be D. It's always going to be one of the non-90 degree directions. So if there's more questions, you only have A and B left. Which vector represents the current through inductance? So voltage is at 0. Current through an inductor lags voltage. Eli. I've drawn that up several times. Eli. So inductive current is 90 degrees behind. So since inductive current is going to be 90 degrees behind, it's going to be B is the answer here. And there was only one left, so they stopped. Which figure below shows the correct vector relationship between the currents in a parallel RLC circuit with a capacitive current that is greater than the inductive current? So that's going to be going up because IC is up. There's only one with them labeled correctly that's going up. So it's C. Because we just in the last few questions labeled all the sides how they should be. You know, I of R, I total, I of L, then I of C was the only one left. All right. That is the last question. 30 minutes. These have gotten long. I want to keep them short, but they've gotten kind of long. Because there's just so much to go over. And to do it justice, I have to, leave it long. I feel like this one is a short one, though. Even though it's 7, 8, and 9. Might be a little long. I don't know. This is the last one for the day. You guys go ahead and get started. Oh, it is long. Probably because there was I think there's 2 questions in lesson 9. And I was like, I'm not making a whole new quiz. Alright, I will see you guys in a couple hours. I might start the stream a little early. And the video will be up, so yeah. Alright, bye.